talking about statistics. Okay. That packet that you guys received at the door, it is covering the first part of the statistics unit, which is the descriptive statistics. Please make sure that you have this package with you every day when we come to class, okay? Because obviously we'll just be continuing on from there. Okay, if you miss a day, then you know you're going to be missing a few pages from there. Sometimes I'll assign some of the problems that are in the packet for homework. Sometimes they'll be just problems working in class, or you'll just get a separate sheet of homework that will be that. But all your notes are pretty much going to be embedded within this little packet. Yes?
This is the entire unit.
No, this is half of it.
Half the unit.
Yes. Okay. If I made the whole thing, it would be like a book.
Too much. It would be too much.
But, you know, with a lot of examples, you know, it is going to involve data, and I didn't want you guys sitting there trying to handwrite everything. You know, it would take us like a month just to do something that could be done in about like a week and a half or something. All right, so from today's lesson, you guys are going to be able to describe the different types of data, create frequency tables, and histograms. Some of these things may look familiar from your times when you were younger, when you first learned about, you know, statistics and things like that. So, you know, I got to make sure, you know, you guys have the basics before we go into the more developed type things, okay? So, to start off, there are two different types of data. You have qualitative and quantitative. Qualitative are the types of data that are not numerically given to you, okay? So that could be like, you know, if you're taking a survey and you're trying to figure out, okay, you know, what's everybody's favorite color? Or, you know, who prefers Skittles over Starburst, et cetera, et cetera. All right? So that's qualitative. Quantitative is when there's actually a number given, okay? It is numerical. Things like that are like shoe size or the number of fish in the pond down at Lake Wills or whatever, okay? Those are your two different types of data, qualitative and quantitative. Now with quantitative type data, there's two different types of data that you can have. You can have discrete data or you can have data that is continuous. All right, so the discrete data. Discrete data is data that can be counted, okay? Or data that can take on specific values, okay? Those are things like the number of people who prefer tea to coffee, okay? I mean, if we were to evaluate this class right here, how many students we got? 14, we got 14 students in here, right? If, you know, if I had you guys vote, would you prefer tea or coffee? Then, you know, I would actually have something that can be counted. I have 9 people for tea, and then, you know, the other 5 for coffee. Or your shoe size, right? 8.5, 7, 9.5, et cetera, et cetera. These are things that can be counted. Hat size, you either wear a 7.5 or a 7 1/4, or if you got a big dome like me, you wear 8, okay? Either or. But these are things that can be counted, okay? But continuous data is data that can be measured, okay? They can take on a value within a range, like weight, okay? Weight can be very much a range, okay? Even though you're like, when you stand on the scale, you get a number, yes, but realize that weight can fluctuate, okay? Depending on what type of scale you step on. Your height takes on a range of values, okay? And time, very much so. Time is something that is measured. It's within a range, okay? Yes.
Isn't like shoe size and hat size, can it be measured too, like the way of
But see, the thing is, the difference between something like shoe size compared to like time is that, like when you like your shoe size is one size. You wear like an 8.5 shoe. You don't wear between the 8 and the 9 type. Like the shoes have one set size. Like when you go and buy a shoe, it's gonna say 8 or 8.5. That's something that is specifically counted.
So how is height?
How's height?
Oh, is it like a value?
It's like a range. It's like a range of values.
Okay.
Like time can take on anything from, you know, between 10:52 and 12:28. Okay, that's a range of time. Okay, versus the shoe size is only one set size. So let's practice this. Okay, you guys have a list of 8 items. You need to determine whether they are discrete or continuous. Okay. You guys are doing this independently. What do you think it is? Do you think it's discrete? Do you think it's continuous? Okay? So I'll give you about 3 minutes to determine, and then we'll go over each one. All right, so say whether it's discrete or continuous. Number 1, the number of sweets in a packet. That's very much discrete. Okay? You open up one of those little fun size, you got about 8 Skittles right there in your hand. The height of students in grade 8, 8th grade. That is continuous. That can be a range of different heights. You can go all the way from 4 foot nothing to 6 feet, whatever. Okay? The dress sizes for a girl's pipe band. I think I heard a mix of it. Say again, what is it?
Continuous. Who said discrete?
Okay. Why? Why do you say continuous and why do you say discrete?
Discrete. Come on.
It is discrete. It is very much like it's very much like
You were anything. I was saying myself.
It is discrete. It is discrete. Dress size, just like shoe size, just like hat size, just like shirt size. They're all discrete, okay? So no. For the number of red cars in the parking lot, discrete. I can go out there right now and count the number of red cars in the parking lot, okay? The weight of kittens.
Continuous.
It is continuous, yes. Kittens are all different weights. The marks obtained by grade 7 on a science test.
Discrete.
That one's actually going to be discrete because each individual person is going to have a set grade, and that is a grade that can be counted. Like right here, like on your mathematical models test, that once I get done grading, there will be 14 grades that you guys will have. Okay, yes, it could range very well from a 50 to 100, but it is one set value that is going to be counted.
Have you
Yes.
graded mine?
No, I
Okay. I low-key want to know what I got. This is the first time I actually want to know what I got on this test. Thank God.
Recorded.
The times taken for students to write their world literature paper.
Continuous.
This one is continuous. We're dealing with time here. We are dealing with time. The number of heads when a coin is tossed 60 times.
Discrete.
That is discrete. Discrete. Because you can sit there and you count it. Like you literally are tossing it 6 times, 60 times, and so you can basically say, okay, that's 1 head, flip, 2 heads, 3 heads, so. But when it's tossed a set number of times, you're able to determine exactly how many heads you have once you toss it all 60 times. Questions? All right. Now, when you're doing statistical investigation, say for a whole group, okay? When you go in and you collect your data, that data is known as a population. So when Ms. Dunstan sends out a survey for you guys, she's going to be getting a collection of the data. You guys are known as the population. Now a sample is a small group chosen from that population. Okay, it's a smaller group. Say we're looking only at IB students, that would be a sample. Or if we're looking at only 9th grade, when you give out a survey to the whole school, that's like an example. Sorry, not an example, a sample. A random sample, each element has the same chance of being included, okay? Very random. Like when the reports come in, say Ms. Dunstan takes every 3rd report to generate her sample. That is random. Because she doesn't care whether it's a grade, if it's a junior versus a senior, if it's an IB student or a non-IB student, it's just every 3rd person, okay? However, a biased sample is one that is not random. Okay, so if she does send out a survey and she only looks at the IB results, then that is a biased sample because she's looking at one specific group versus a random. Does that make sense? Yes.
But could you then select a random group from inside that bias sample?
Yes, you can. So once you take just the IB kids, then you can say, okay, now as they come through, I'm taking every 3rd one. Then that could be random, but it's within a bias sample. We good? Well, let's see. Let's practice. Determine whether these are random or they are biased. You have 4 of them. I'll give you a minute. Determine if they're random or they are biased. Okay, so let's determine if these are random or biased. When researching if people eat breakfast, only interview the people in the canteen. And before you ask, canteen is like a cafeteria. Okay? So, is that random or is that biased?
Bias.
It is biased, okay? Because, you can go outside of just the cafeteria. You can go to, the courtyard or the front office or wherever, okay? When When researching spending habits, interview every third person you meet. That is random. When researching spending habits on cars, Josh interviews men exiting the garage. Very much so. Okay? You're going to interview the women. Okay? When researching the sleeping habits of children, Adam distributes a questionnaire to students in his school.
No, it's biased. No,
It's random though, because it's not picking
Well,
specific.
but he never said, no, if you would have said it's the people in his school, that's different. It's biased, right? It's biased.
It's a sample of people from his school. He's not picking a certain amount of kids.
He could have gotten different schools. He chose this school.
It is biased. It is biased.
So
I stood by my.
If it was, okay,
Yes.
if it was when researching the sleeping habits of students at his school, then it would be random.
It'll be yes, but this one is sleeping habits of children. There are children who are not at his school that he could also interview. To also go along with that, we're in the second semester. We're going to be starting talking about IAs as soon as we get done with the statistics unit, because a lot of times study students tend to do their IAs that are mostly statistics based. If you are going to do something where it comes down to collecting data and things like that, you might also want to keep that in mind. The more random you are, the more likelihood that you'll get a kind of a good spread of data, because you'll have all different types. But if you do decide to make yours a little bit more biased, like only interviewing certain people, then that's also going to have a type of effect on your results as well. But we'll talk about that later. Different things to keep in mind. All right, simple discrete data. We're actually going to get into some math here, okay? When there is a large amount of data, sometimes it's easier to interpret if the data is organized into a frequency table or displayed as a graph, okay? So, a frequency table is basically a table that outlines all of your data nice and neatly, okay? So right here it says the number of sweets in 24 packets are shown below. You have 24 different packets, and this is the number of sweets that are in each one of the packets. Now this is, 24 is really not a lot, but it could have been more, all right? But all this information can be organized into a frequency table, okay? Literally, a table, okay? We have the number of sweets that actually show up in each one of the 24 packets, and then we actually have the frequency. Okay, frequency basically means how often these particular numbers show up, okay? So out of these 24 packets, how many sweets do we have in these packets? Like, what are the numbers? What are the range of numbers?
24.
So you're saying that there's some packets that have 20 in them?
Yeah.
And 21?
Yeah.
And 22?
Yeah.
And 23?
Yeah.
And 24?
Yeah.
There are no 25s or 19s or anything like that? All right, so these are basically the numbers that we're kind of floating in between. Now, how many packets actually had 20 sweets in them?
2.
There are 2. You have one here, and you have one here. So we would basically say that the number 20 showed up 2 times out of the 24. What about 21?
3 times.
We got 1, 2, and 3. And we are creating our frequency table. You guys see how this is? Pretty simple, right? 22, how many?
13.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. You're wrong. How many 23s? 4. 1, 2, 3, 4. And how many 24s? 2. This is a frequency table. Now, one thing is that the number that you have in your frequency should add up to the total packets that we have. Do these numbers 2, 3, 13, 4, and 2, do they add up to be 24? Very good. So then we have our total of 24. And it should, okay? If it doesn't, then we made an error somewhere.
If it does, it could be like a trick question, and this question is not proper, that this is wrong, someone missed a penny. That could be a thing.
That could be a thing, but if it does show up on your IB exam, they usually send out something along with the scores that says, hey, we decided to give the students these points because there was a mistype on our part.
What if it was a trick question to begin with?
That's your question. It would just be a mistype, if anything.
Okay.
All right, I want you guys to do this one. Do this one on your own. Give you 2 minutes.
Yeah.
All right, what's the frequency for 8 days? okay? Just in case you might have zoomed through it too fast and you missed one. 4 plus 6 plus 4 plus 3 plus 4 plus 1 is indeed 22. Good stuff. Questions up to this point? Pretty simple, yes? Yes?
Yes.
Yes, it should be. Okay? Now, when there is a lot of data values spread over several numbers, over a wide range, okay, it is useful to group the data sometimes, okay? And when you are grouping data, a couple things you want to keep in mind. If you ever have to create the groups yourself, you want at least 5 but no more than 15 groups. Those groups can also be called classes. Okay, they might say group this data into classes and this new groups. Make sure they're of equal width. You shouldn't have one class be like ranging 5 numbers and the other class ranging 2 numbers. That's just silly. Make sure they're equal width. The classes must cover the range of values, and of course the classes should not overlap each other. So we're going from 2 to 5, then the next class we should go from 6 to whatever. Okay? So, Lonnie made 30 telephone calls in 1 week. The times of the calls in minutes were recorded. These are the different times. We're going to organize this information into a grouped frequency table. Now, when you are putting this into a group frequency table, you want to find the largest number and the smallest number, so then that way you kind of have an idea of what you're dealing with. What is the shortest phone call she made? 1.2 is located right here. It's the smallest. It's the largest. Let's double check this, yes? Okay, cool. So that's the smallest value, that's the largest value. We want to make sure that and everything else lies in between there. Now when we create our groups, okay, we want to make sure they are at least 5, no more than 15, and they have to be of equal width. Okay? So what do you think our lowest number should be for our group? 1. Do 1. Okay? If we do 1, then what's going to be our largest?
36.
Well, like, I'm talking about from the smallest number to the largest number, and then we'll worry about the groups. So we'll go from 1 to 36. Now my question is, if we go from 1 to 36, are we going to be able to have equal groups?
No.
You're saying groups of 7? Okay, so if we go from 1 to 36, that means we're going to have 5 groups of 7, or 7 groups of 5.
5 groups of 7.
Or
We can either go 5 groups.
Let's do 5 groups because it's a smaller amount of groups, so it's easier.
Okay, so that's how we're going to base our table off of, okay? On this side, we're going to have our times, and of course it's in minutes, and then we're going to have our frequency. Because we're still making a frequency table, except this time it is a grouped frequency table. So, 5 groups of 7. That means our first group should go from 1 to
1 to 8.
1 to 8. Okay. So when you write this group, okay, and depending on how it's written, it could be written like 1 to 8, like 1-8. Okay. It could also be written as an inequality because we're including 1 and we're including 8, aren't we? In this group, 1, 2, 3, 4, 5, 6, 7. Are we including 8?
Less than
No, it's right at the brink of 8, so the next category will go 8 to...
Okay, so we're not including 8. So we're basically going from... So we're basically including 1, and we're going all the way to 8, but we're not including 8, correct?
Yeah.
Okay, I just want to make sure. So then the next group would be including 8. We'll go all the way up to what number? Is that equal with? 9, 10, 11, 12, 13, 14. Yep. Okay. The next one would be 15 to what?
22.
But not including? I wrote 2. The next one should be 22 to what? So then the last one should be 29 to 36. Now, are all these groups of equal width? Yep. then basically what you do is any numbers that fall within these time frames, you're going to list them here. And the total should add up to be what number? How many phone calls did she make?
30.
30. So that final number should be 30, okay? So right now, I want you guys to go through your list of data, and I want you to find the frequency. So any number that falls in between 1 and 7.9999. List how many phone calls were in between those time links. Do that now. What's the frequency for the first group?
15.
15?
Yes.
All right. For the next group?
5.
Group after that? Group after that?
3.
And the group after that?
2.
And that does add up to be 30. Moving forward. To find the upper and lower boundaries of a class, calculate the mean of the upper value from one class and the lower value from the following class. Okay? So in this case, here's another grouped frequency table. Okay, talking about shoe size and I guess the number of people that they interviewed, number that were sold in one day. And it's actually to find the upper boundary of the first class and the last class. So to do that, you need to find the mean of the upper value of one class and then the lower value of another class. Now the upper value clearly is the larger value of one class, and then the lower value is the smaller value of the other class. And you have to find the mean. Does everybody know what mean is? What is it?
Average.
It is the average, okay? And how do you find the average? Then add them up and then divide by the number, okay? So the upper boundary of the first class and the last class. There's two questions inside of one. So if you're looking for the upper boundary of the first class, that means you need to take the upper value of the first class and then the lower value of the next class and find the average. What's the average of that? Say again? 19.5. 19 plus 20 divided by 2, halfway is 19.5. And then for the last class, what is the upper boundary? So that means you got to take the upper value of one class and then the lower boundary of the next class. What's actually if I were to keep going, what would be the next value? 45. So what's the average between that? You add them up and divide by 2. That is the upper boundary of the first class and the last class. Now I want you to find the lower boundary of the first class and the fourth class. Find the lower boundary. Alright, so we have to find the lower boundary now of the first class and the fourth class. Remember, class is just another word for group. So if I'm trying to find the lower boundary of the first class, I'm going to look at 15 and what other number? 14 for the first class. Okay? What's the average for that? 14.5. You add them up together, divide by 2, and there you go. The fourth class, that's 1, 2, 3, 4. I'm looking for the lower boundary of the fourth class. I'm going to take 30 and get what? Questions on finding upper and lower boundaries?
Wait, so why do you put first? Why do you use 15, 14?
For
No, the first one.
because you were looking for the lower class, that means you're going to take the lower bound of the first class and then the upper bound of the class. Because you're looking for that particular boundary for that class. Questions on frequency tables, how to read them, how to use them.
But then why on upper boundary do you take one high, one low? But then on lower boundary you take both low.
Because remember, with the lower boundary, we're looking at the smaller number of that particular class, and then the one before it. So that's why we use 15 and 14 for the first class, and then for the fourth class, we're using the lower boundary for the fourth class, and then the higher boundary of the class before it. If it's the upper boundary, then we use the upper bound for the first class, and then the lower bound of the class that follows it, and then for the last class, it would have been the upper boundary for the last class, and then the one that goes after. So if you're thinking lower boundary, the smaller one and the one before, upper boundary, the higher one, and the one after. Frequency histograms. These are, you all have dealt with histograms before. You probably never knew that they were called histograms, but they are basically a bar graph that have no spaces in between them. Okay? To draw your own frequency histogram, you have to find the lower and upper boundaries of each class. Draw your bars in between these boundaries, of course, no spaces. The x-axis is your class boundaries. And then your y-axis is the frequency values, okay? Whenever you have to draw one yourself. These are some things that you need to keep in mind. All right? So, flip over. We are drawing a histogram for the last example that we just did, the one that was related to shoe size, okay? And so when we draw this histogram, like I said before, we need to find the upper and lower boundaries. And then we're going to draw our bars. The x-axis represents what? The boundaries. And then, so our boundaries were technically our shoe sizes. We always want to make sure that we label. We always want to make sure that we label. And then our y-axis is going to represent what? The frequency. It's pretty easy. First column is x, second column is y. Okay? As we can see here, looks like our largest value is 45, our smallest value is 3, so maybe 1, 2, 3, 4, 5. Maybe not go by 5s, but go by 9s. That way it can fit everything. So 9, 18, 27, 36. Always make sure that if you ever have to draw, said this before, but I'm going to reinforce it. Every time you have to draw your own graph, all you're given is a blank grid or a blank x and y. You yourself have to put in the labels. You just can't randomly draw an exponential function coming from some spot on the y-axis and expect me to know that that's a 2. Anybody do that on their test?
I had to come talk to you about it.
Yes.
Oh, I thought you were talking about labels.
What's it to sketch the graph?
Yes. Labels is what? Even with the sketch, you still need to have like some numbers associated with it, because if that graph is crossing the x-axis, you gotta have some type of labeling where it's crossing the x-axis
Even with the
or the
sketch
y-axis.
But I thought
gotta-
sketch was just showing that in like a general.
Yeah, I thought.
That's what I thought sketch
I thought
means.
sketch was like to show a general term and you went.
How should we label the bottom? How should we label the bottom?
By each range, range class, 15.
Well, no, we're looking at these boundaries.
Yeah, 15 to 19.
15 to 44. So what do you want to go by? 5s, 10s, what?
Yeah, let's do 5s because it'll go to 14 or 45 by the time we get there.
Just do fives.
We should do 5. Oh, no, you're
No, we gotta hit 44.
We gotta do 10s then.
10s? Okay. Basically, whatever scale you make, you stick with it and you label. Okay?
We know that now. Once it ever makes that mistake again.
We couldn't go by 5s because if we started here 5, 10, 15, 20, 25, 30, 35, we wouldn't be able to include this last class. You see?
Why is there a shoe size of 44?
It's European.
European.
Kyle, open-minded.
So now,
My brain doesn't function.
People have big feet.
from 15 to 19, 15 is about halfway here, and 19 is right before 20. You need to draw a bar graph that goes up to 3. And there you go. Do you have to spell it in? No, you don't have to. You just make a little bar. But the next bar for this histogram needs to make sure there's no spaces in between. Okay? So then we go from 20 to 24 up to 9. 20 to 24. 20 to 24. Halfway there. And you basically, all you're doing is making an old school bar graph, like what you did in elementary school. Yes, exactly like what you did in elementary school. Okay? 25 to 29, you're going up to 12.
4 of them.
Alright? You guys finish off your histogram. 22, so on and so forth.
So.
I'm listening, go ahead.
Start. What? Would they still touch if it's like the 19 and 20? They still. Yeah, isn't there space between those numbers? Or would you do like 19.5 and then 19.5?
What is average?
You okay, buddy?
Make it a marker.
Yeah, you okay, buddy?
31. Once you have your histogram done for this one, do the next one on your own.
We have to draw the boxes for the histogram. Oh,
You have to draw the boxes.
This one you do yourself, but this one's actually, when you think about it, it's actually a little bit nicer because then you're not kind of like stuck between like, trying to figure it out.
Dumb numbers.
You're drawing this yourself.
Two jokes are like.
This one's what you
One
should have
second
had for
apart.
this, for the frequency diagram. The histogram. Okay? For example, again, you're just making bar graphs, making sure they connect, doing your best to try to stay even. Now, you have to write down the upper and lower boundaries of the fourth class. Okay? The fourth class, 1, 2, 3, 4. The lower boundary, what did you get? 15.5. The upper boundary.
20.5.
Very good. All right. We have another one. Do the next one, the one on the next page.
Why didn't you do like the one where it's
Oh, I did. So here, and here, that's how we got 15.5 for the lower, and then 20 and 21. That's how we got the upper.
so you added divided by 2?
Uh-huh.
I got 18. I got 16 plus 5.
Make sure you have 16 and 15.
Oh, I think I did that one.
So you're doing the next
Paul
example
Blart
as
flash
well.
mob.
Doing the next one. So you should have gotten this with your graph, okay? I just decided to use a little bit more of the space of the graph that was provided. If you do your standard, that's fine. And if you label yours different, that's fine as well, okay? Just make sure that the main thing is that you have your labels, you have your X and Y axis labeled as well with time and the number of visitors. Questions on histograms? We're gonna go forward.
I'm not done drawing.
For now, we all need to talk.
No, definitely. All right, measures of central tendency. Getting a little bit more deeper into the math. Data can be summarized using the following things. You guys should remember this. What is mode?
The most of them.
The movie.
Most. It stands for how the piece of data that occurs the most. Median.
Middle.
It's the number that's in the middle, and you have to make sure when you're defining the median with something that can be helpful.
You put it from least to most.
Yes, least to greatest. Okay, because sometimes your data just can be everywhere, so you go from least to greatest. Okay? And then this last one, mean. We just talked about what is mean.
It's the mean one. It's the average.
It's average, and you find the average by doing what?
No.
That's range.
Oh.
You add up all the numbers and divide by the number of numbers.
I thought it was average.
That's what an average is.
You tried to.
Okay? So you add it all up and divide by however many you have. Good, so you guys haven't forgotten that. So since you haven't forgotten, I'm going to allow you guys to do this one on your own. Find the mean, median, and mode.
Wait, I forgot.
I got to fix something.
Oh
There you go.
I missed the 4. Sorry.
There's 2 4s.
No.
Yes.
I already
There's
made my
2
number.
4s right there. Fix it. And
And
find your mean, median, mode. All right, so as you guys, after adding in that extra 4 as well, what was the mode? The mode was 4. After adding in the 4, what was the median?
5.
What was the median?
5.
It was 5. Because if you list them in order, that's 1, 4, 4, 4, 5, 5,
I got 4.
7, 8, 9, and 11.
There's one more.
Oh, there's 2 5s?
Yeah, I thought it was 4.
I thought there was only 1 5.
There's a 5 at the end. Do you see it?
There's a 5 at the end, so when you cancel,
Okay, it's still on your paper.
It's not in Spanish. You can't read it.
Alright.
and the last one is the mean. Go back in, guys. You add them all up. What was the total?
66.
Okay.
And then you divide by how many there were. How many were there?
11.
So you should get a total of 6. Okay, now there is a calculator way to do this, to figure this out. Okay? So everyone pull out their calculator.
Whip it out.
Okay? And you need to follow a few simple steps. The first step is you need to press stat and go to option 1. This is what your screen should look like before you click option 1.
Okay.
Does everyone's screen look like this? And then press option 1, it should look like this.
Like that? Not looking like that.
Of course, it doesn't have numbers. You have to type in your data.
Oh.
So once you get to your list, you have to type in your data. If you have data, raise your hand if you have data already in your calculator. There are already numbers already in there. No? Okay, cool. Then just type in all your numbers into L1. You type a number, click enter. Type a number, click enter. So, and this is the data that's actually on your paper.
Do they have to be in order?
No, they do not have to be in order. Because the calculator is actually going to do that for you.
So it's a number, then I hit enter. Or?
Yep, a number, then you hit enter. And then after you type in your data, you press stat again. So you go back and you press the stat button again, and you click the right arrow over so that calc is highlighted.
Oh.
So everyone's screen should look like this after they get all their data typed in. Now from this point, you're going to click enter. Okay? Click enter on option 1. Okay? Now some of you guys, it may take you back to the home screen that says 1-bar statistics. Some of you guys may have a list that says 1-bar statistics, type, and it says L1, yeah? Anybody's calculator does that?
Mine just says 1 bar stack.
Okay? If your calculator does that, when you go to stat over to calc and press enter, just go down to calculate and click enter. If yours doesn't look like this and it just shows 1-bar statistics on your home screen, just click enter. Okay? When you click enter, it's going to pop up all this information. Okay? We are going to use all this information at one point in time. This very top one, it has an X and a bar. That is your mean. X bar means your mean. Okay? Some of these other things I'll talk about when we get there, okay? This one right here where it says n equals 11, that should match the total number of pieces of data you had. We had 11 pieces, so n should be 11. If you scroll down, just press the down arrow, you'll get these other options. MED stands for median. So MED equals median, which we got to be 5, correct?
Yep.
Okay. And there's no option for mode. You just got to figure that one out yourself. Okay?
That's kind of lame.
All right, you got to figure that one out yourself. But that's how you do using the calculator. So if you're ever given like a lot of data and it actually find the mean and median, you just type it in. Doesn't matter what order it's in, and just follow those steps, okay? All right, continuing forward. Let's look at this problem. It says for these data, I should say this for whatever. The mode is 5, and the median is 6, and the mean is 6.5. Here's your data. Now, if you notice, this data has 2 variables in it. And given that S is less than T, find the value of S and the value of T. Okay? So, we have to use what we already know, that the mode is 5, the median is 6, and the mean is 6.5 to find S and T. It says S has to be less than T. It might be a little easier to find S first. Okay? What do you think S is?
5.
S would have to be 5 because if the mode is 5, that means that 5 has to be the one that shows up the most. So S is 5. Now we have to find T. Now the fact that the median should be 6, okay? And to be honest, it really doesn't matter. Like, we're going to end up being right here. The median is not actually going to help us figure out the value of T because it's technically just a placeholder. But the mean is. To find the mean, we need to add up all the data, divide by however many we have, and that will equal your mean. Right? How many pieces of data do we have? How much is this? Including the variables, how many pieces of data do we have?
14.
14. Okay? We know the mean is equal to 6.5, and technically we can actually add all these numbers up together except for T. So let's do that. Let's add 1, 1, 2, 3, 5, 5, 5, 7, 8, 9, 10, 12, 12. Add all those up. what you have is an equation that can help you find the value of t. Because when you add up all the pieces of data and divide by 14, you should get 6.5. How do I solve this equation? So you get 80 plus t equals, what's 14 times 6.5? 91. Then to solve, we're going to subtract 80. So t is going to be what value? 11. Now you can sit there and you can try to figure out values that would actually give you the mean, okay? And yes, even though it's in order, probably limit down your choices. But if the stuff is not in order, then what are you going to do? I mean, you can. I mean, this could really save you some time because you know we are being timed. So you guys are going to do the next two examples on your own. So I'll give you about a few minutes and we'll check back in. So with this one, Jen obtained marks of 76, 54, and 65 on his physics, biology, and history exams respectively. Calculate the mean for all three exams. Simple enough. 76 plus 54 plus 65 divided by 3. What is that?
65.
No, like the final thing after you divide by 3. 65. Okay? So his average was a 65. Now it says find the mark that Jim must achieve on his math so that the mean mark for the 4 exams is exactly 65. Okay? So it has to be exactly, I'm sorry, 68. So that means he's now going to take 4 tests, not 3. And that math test would have to be added to the total he already has. What's the total here? 195. Multiply both sides by 4. What is 68 times 4? 272. Subtract 195 from both sides, and so his math score would need to be a 77, so that his average for all 4 tests could go up to a 68. Everyone get that? Now, Zoe and Sean compared their test scores. Zoe had a mean of 81 after taking 5 tests, and Sean had a mean of 78 after taking 3 tests. Each of them took 1 more test and ended up with the same mean score of an 80. Okay? So find the grade that Zoe gained on her 6th test, so that way that her score could be an 80. Okay? Now, if you think about it, we don't know what how many tests? We don't know what the scores were on the 5 tests, but we do know that the average was an 81, right? So basically what we can do to figure out, exactly what that was is basically by multiplying 81 5 times, okay? Because the average was an 81. So it really doesn't matter, exactly what numbers they were, essentially. Some would technically be the product of multiplying 5 by 81. She took 1 more test, which makes for a total of 6 tests.
Also, it's basically
But the thing is that since we don't know what each individual test was, to add it up to find the sum, you can multiply the average by the number of tests she actually took. So since she took 5 tests, and the average was 81, you just multiply it there, add it to the 6 tests, divide by 6, solve this out. What's 6 times 80? 480. And what is 5 times 81? So if I subtract, then that means that Zoe on her 6th test, she got a 75. Right? We do something similar to that for Sean. He only took 3 tests and scored an average of a 78. So 3 tests at an average of 78 plus some 4th test, divide by 4, because he's taking 4 tests, he needs to get a mean score of an 80. So what is Sean going to need to get on his 4th test? An 86. If you multiply 4 by 80, you get 320. What's 3 times 78? 254? 34? So he'll need to get an 86. Be very helpful as well on your SAT, ACT if they ask you anything similar to this. Questions? This last bit, with the frequency table, finding the mean, median, mode is a little bit different, okay? In a frequency table, the mode is the entry that has the largest frequency. The median is technically the middle entry, just like before, because basically what you're doing is you're allowing the table to basically organize your data into neatly, putting all the same numbers together, then the next same numbers together, so on and so forth. It can also be found algebraically by doing n plus 1 divided by 2. N represents the total number of data. To find the mean, though, of a frequency table, you have to realize that these numbers are occurring several times within the data. So what you need to do is to take the total of Fi times Xi. Fi represents the frequency of each value, and then of course Xi represents, like, first value, second value, third value, so on and so forth. And then you divide it by the total frequency. So we're gonna look at an example after you guys copy this down. Alright, so we're gonna look at this example. Going back to the sweets example. Okay, we're gonna calculate the mode, the median, and the mean. So the mode, remember, it is the entry that occurs the most, that has the largest frequency. Which one has the largest frequency? 22. So our mode is 22. That meant that 22 showed up the most times in our data. If you think about it, we had the data already laid out, and it really did show up the most. The very first example we did when we started doing math.
Oh, this
This is the sweet example from before. Yeah. Not just determining things you discrete and random and continuous. Okay. The median is the middle entry. Okay. Now, if you think about it, the two 24s are going to cancel out with the two 20s, correct? Like if you were to look at the list and cancel out, right? Now, the four 23s are going to cancel out with the three 21s and then one 22, correct?
Yes.
So then you're basically going to be canceling out 22s all the way to the middle. So what's your median? 22. Now another way to figure this out is, that's what the n plus 1 divided by 2 I was talking about. N represents the total number of data that we have. So basically the frequency. If you plug that in, 24 plus 1 divided by 2. What is that? 12.5. So basically this lets you know that the median occurs at the 12.5th entry in this data set. If you count 2 plus 3 is how many? 5. Plus, what's 5 plus 13? 18. The 12.5th entry is going to lie between right here within the 22 range, because you basically have 18 pieces of data by the time you reach the end of the 22s. And since there were 2 here, 3 here to make a total of 5, your 12th entry is going to be here with 22. Everybody understand that? All right, I'll finish this up on the video. You guys make sure you watch the rest of the video, and then you're going to finish the 3 examples that follow this one. That's going to be your homework, to finish the 3 examples that follow this one. I'll see you tomorrow. So lastly, to find the mean, that is the formula where you multiply Fi by Xi and then divide it by the frequency, the total frequency. So to do that, I'm going to do that right over here. I'm going to multiply all of my x's, which are my number of sweets, by my frequency. So let me erase this so that way I can see everything. We're going to have 2 times 20, which is 40. 21 times 3, which is 63. 22 times 13, which is 286. We're going to have 23 times 4, which is 92. And then 24 times 2, which is 48. We're going to add all those up to get 529. So this numerator is the total that's gonna be 529, and we're gonna divide that by our total frequency, which is 24. And when we do that, we get a mean of 22.0 using three significant figures. Now I know you're like, well, is the mode and the mean and the median all gonna be the same when you do these? No, they're not. But you gotta go through the math to determine if that's the case. Okay? So you're gonna do the next three problems for your homework and be ready